Hello students, today we are going to study the occurrence of carbon. Okay, it occurs in the free form as well as in combined form. When we say it occurs in the free form, okay, it occurs in the form of allotropes, that is the diamond, graphite, the Fullerene group, basically Buckminster fullerenes consisting of C60, 60 atoms of carbon forming what? Buckminster fullerenes. Now, when we say about the combined state, okay, so it occurs in the form of carbon dioxide, carbon monoxide, hydrogen carbonate, organic acids, organic compounds, okay, and there are many others. So when we are seeing about the pure form of carbon and in the combined form, the pure form, it is very less in present, okay, and those I said that in which form they occur in the pure form, in the form of diamond, graphite and the Fullerene's group or the Buckminster fullerenes, basically, which you have to study. Now let us study about the allotropes of carbon. So what are these allotropes? Actually, when an element exists in more than two forms, okay, what happens? And they are having same chemical properties but different physical properties because of the arrangement of the atoms, okay, they are known as what? Allotropes. And yes, the phenomenon is known as allotropy. Okay, so now there are three crystalline allotropic forms of carbon. What are they? Diamond, graphite and the Fullerene group. We say these giant molecules. Why do we say these giant molecules? Because here long carbon chains are present. Okay, yes, the arrangement will be different, but yes, as it is made from the similar element carbon, they will have same chemical properties, but due to the arrangement of these carbon atoms, they will have different physical properties. Okay, so let us study first diamond. Okay, so when we talk about the diamond, okay, it is the hardest non-metal, isn't it? And it is the hardest substance also, and it is one of the purest form of carbon. Why? It is the purest form of carbon because it is just made up of carbon atoms, okay, and it is crystalline in nature. Let us study about the structure of this diamond. Okay, here we can see one carbon atom is joined to other four carbon atoms. Okay, so here what happens in this carbon atom is linked to the other four carbon atoms, so thereby when it is being linked, okay, no space is left empty, okay, and as the result it forms a compact structure, okay, and the bonds which are present between them is the covalent bond, and making it what? This strong covalent bond, because there is no space in between. All the carbon atoms are joined to other four carbon atoms, and we can see the angle in this. It is making an angle of how much? 109, okay, degree 28. Okay, this gives it a tetrahedral shape also. Okay, so here as this strong covalent bond is present, okay, so it means it will give some properties to it. Okay, so what properties it will give? Let us study. Okay, so due to this strong covalent bond, compact structure, okay, it is very rigid, okay, in nature. And yes, this compact structure also, because of this, the melting point and the boiling point also becomes too high, and so tremendous amount of energy is required to break the bond. Okay, it is a good conductor of this heat. Okay, but yes, it is not a good conductor of electricity. It is an insulator. Why I am saying that? When you heat this diamond, okay, to a very tremendous high temperature, okay, what happens? It will also burn and give out what? Carbon dioxide. So it is a good conductor of heat, but it is an insulator, a non-conductor of electricity, because here compact structure of carbon atoms, you can see no free electrons are present, and yes, if free electrons are not present, so naturally it will not conduct the electricity. Okay, now talking about the density, yes, compact in nature, too compact in nature, okay, closed packed structure, density also becomes high. Okay, now here we see when we talk about this diamond, okay, it is too lustrous in nature, very shiny in nature. Why? They are so lustrous in nature because there we can see that the refractive index of diamond is very high. Okay, and yes, when diamond is heated in the presence of oxygen, okay, as it is made up of carbon atoms only, it will give out carbon dioxide. Okay, now let us study about the uses of this diamond. Okay, this diamond, you know, it's mainly used for making jewelry, which is very costly. Okay, how do we measure this diamond? We measure in terms of carats. Okay, so when we talk about 1 carat, it is equal to 200 milligram. Okay, now these diamond chips are used to make the surgical tools and the surgical knives. Okay, and black diamond is used for cutting and drilling. So there are a number of uses of diamond also. So this I am talking about the pure form of diamond, which has been made from carbon and has taken millions of years to be made. But yes, diamond can be made artificially also. Okay, how can it be made artificially also? Actually, if we provide high temperature, okay, more than 1800 Kelvin, and yes, pressure 50,000 to 60,000 atmospheric pressure. So temperature also high, pressure also high, thereby it can convert carbon into a artificial diamond. Okay, and they are very cheap in the market, you all know it. Okay, and who was the one to make the first artificial diamond? He was Henry Moissan. Okay, and now we are going to study about graphite. So graphite, how does it look like? It is actually grayish black opaque substance. Okay, it is not transparent, opaque in nature. Okay, and it is grayish black in color, and yes, because of this it is also known as, commonly known as black lead also. Okay, so when we study about the structure of this graphite, okay, you can see the hexagonal rings over here. Okay, actually here in the structure of graphite, hexagonal rings of this carbon atoms are present. Okay, here one carbon atom is joined to other 3 carbon atoms. Okay, and yes, the 4th one is free. Okay, and this free electrons, when we are saying that yes, the electrons are free, it means it will conduct electricity. Okay, so here we are saying that each carbon is linked only with 3 carbon atoms. Okay, and the 4th one is free in nature, which makes them a good conductor of electricity. Okay, it makes graphite a good conductor of electricity. And here you can see that yes, this graphite has got a layer like structure, and here weak forces are present. Okay, and those forces are known as van der Waals forces, and these van der Waals forces only makes this graphite slippery in nature. Okay, it makes it slippery in nature. It can slide one above the another because of the presence of this van der Waals forces. These are weak forces. So we see over here, this graphite is not having a compact structure like that of diamond, which were having a 3-dimensional structure. But here graphite, as one of the electron is free, one of the carbon atom is free. Okay, what happens in this? Here it gives a 2-dimensional structure to the graphite. Okay, so here because of this structure of this graphite and the presence of the van der Waals forces, it has some properties. Okay, so what are those properties? It is a good conductor of electricity. Naturally, it will be a good conductor of electricity because the 4th valence electron is free. And yes, if the electron is free, it will help in conducting the electricity. Okay, now as these van der Waals forces are present over here, it is what? Soft as well as slippery in nature. Okay, and yes, here they are not so lustrous like we have seen in diamond. Okay, they are black in color, they are opaque. Okay, so the lustrous property like that of diamond is not present in case of graphite. Okay, and graphite, as we have seen that yes, here weak van der Waals forces are present. It makes it what? Brittle in nature. The whole structure of this graphite makes it brittle in nature. But when we talk about diamond, it is not brittle, it is very hard. Okay, now about the uses of this graphite. Okay, it is used in making what? The pencil leads. Okay, now in printing press. Okay, ink. Okay, carbon paper also can be made, blackboards can be also made. Okay, brushes of the electronic motors can also be made. Okay, and yes, here as we are seeing, it is having a free electron, okay. It can be used to make electrodes, okay, and yes, thus as it is a good conductor of electricity, electrodes can be made of graphite, okay. Now this was about the graphite, its occurrence, okay. Number of atoms of carbon more, the more bigger will be the structure of graphite, okay, and yes, the number of carbon atoms less, the size of the graphite will be less, okay. So this was about the carbon in the graphite form existing in the pure form, okay. And yes, when we see the graphite, it occurs more in nature than the diamond, okay. So here graphite occurrence is more than diamond, okay. So but yes, graphite can also be made artificially, okay. How can it be made artificially? We can take coal, okay, the anthracite form of coal, okay, and we can add what? Silica to it. And when we add silica to it, temperature should be 2273 Kelvin, okay, or it can reach to 2773 Kelvin also, okay. And here you can see that it changes into what? Silica carbon, and then yes, it changes into carbon in the graphite form, and silicon is given out, as well as naturally carbon dioxide will be given out, and we will be getting the artificial form of graphite over here, and it can be prepared from the anthracite coal, okay. So now we will be studying about Fullerene group. So Buckminster Fullerene, okay. Well, it is named after an American scientist, okay, R. Buckminster Fuller, okay. And these are what? These are giant molecules, very big molecules, okay, made up of 60 to 350 carbon atoms, okay. But yes, this carbon atom should be even in number, okay. When we talk about this Buckminster Fullerene, okay, the most stable form is C60, okay, and this it means it is made up of 60 carbon atoms, and it is made like a ball, okay. So it is known as what? Bucky ball, okay. Now this C60 Buckminster Fullerene, okay, it is a dark solid at room temperature. When we see it in room temperature, it is totally a dark solid, okay. It consists of 20 hexagonal rings and 12 pentagonal rings, okay, and these are joined in an alternate manner, okay, and they fuse to form a 6-membered ring, and thereby making it look like a big ball known as Bucky ball, okay. So when we talk about the hardness of this Buckminster Fullerene, okay, its hardness is in between diamond and graphite, okay. It is not so hard as diamond, and yes, it is harder than graphite, okay. Yes, when we talk about the preparation or how can we make this Buckminster Fullerene, okay, it can be made by vaporizing the graphite using laser, okay, and by heating graphite rod electrically in the atmosphere of helium. So this was all about the allotropes of carbon, okay, in which carbon exists in 3 forms we have seen, okay, diamond, graphite and Fullerene, okay, and in the pure form of carbon having, okay, what? Similar chemical properties but different physical properties. So hope you might have understood, students. Good day, take care.